right. Get a blank piece of paper if you haven't already. Some of this test is easy, some of it's hard, so I guess overall it's kind of a mix. Kind of in between. I hope number one's easy at this point. I won't take it for granted that we know that. There will be a number line on the test for you if you want to. I feel like maybe we're like at Wyatt or something somewhere in there, I think. I don't know how far we got yesterday.
At Wyatt?
Yeah, we are way down there.
No, let's just, I say we just start with Wyatt. Yeah.
We should start with Ellen.
We should start with Owen. We should start with Wyatt.
Wyatt,
He thinks we should start with Owen.
I hear
We
it.
start with
Just me.
But I don't wanna know.
Yeah, it's not democracy. Wyatt, you are the chosen one. What's x's less than 3 look like?
And open circle at 3 left.
Yeah, so that one's so bad, wasn't
That was painful.
it? Okay. It's 3 and 4 that people start getting wrong. Number 2, Sophia, what does that look like? Close circle, because there's an equals to. Going right. These kind of match the arrows. Okay, this is where it usually goes wrong. Jonathan, do you remember how to set up greater than? With absolute value. That's the difference.
Should just be x is greater than 6 or x is less than negative 6?
Yes. Okay, that's how it's written. How's it graphed?
Open circle at negative 6 and open circle at 6 and a line in between them.
No. So what's x is greater than 6 look like?
Oh, the line from 6 going right and
Alright. What's
Oh.
x is less than negative 6 look like?
line going to the left.
Because it's an or, it's okay, they don't have anything in common. I suppose if you forgot, maybe you could stop and think about it. What numbers would work right here? 7, 8, 9, but also like negative 7, negative 8, negative 9. That's all these numbers or all these numbers. Okay, Bo, do you remember how to set up number 4? It's the one that people get the most wrong.
Is it negative 2 is greater than or equal to x and less than or equal to 2?
Close. It's, yeah, they're both less than or equal to. Negative 2 is smaller than x, which is smaller than 2. In other words, x is between those two numbers. Yeah, grading this homework has not been fun. Anyway, on this, this is Monday's assignment, these two. There'll be a couple more like it later on that we don't graph. Okay, how do we graph that?
You put a closed circle at -2 to the left.
No. See how x looks like it's between these two numbers? That's because it's between those two numbers. So that means all the numbers in between are part of the answer. So it's just a line between those two. So you guys might want to study 3 and 4. Yes, you can study for math. It's not memorization, it's a different kind of studying. Studying for comprehension. Alright, then it gets kind of easy again after that. Or easier, I shouldn't say easy in case somebody gets it wrong, but it's just going to say solve. Alright, do we need to do any special weird setup tricks for this one? No. Why is this one simple? There's no absolute values. You don't have to do anything weird, just do normal stuff. No, we're not graphing. The directions are just solved right there. Do that. Ooh. All right, Jackson, what would we do on number 5 to solve? Add 7. Okay, if you just put 19, that would technically be wrong. It's x is less than or equal to 19. All right, Atticus, what would we do on number 6? No, this is, you would add 5 if it said x minus 5, because plus 5 gets rid of a minus 5 since they're opposite. But this is -5 times x, so how do we get rid of a multiplied value? Divide. Okay. What did I do wrong?
You didn't switch this.
Okay, when you divide by a negative or multiply by a negative, the inequality should switch. So you have to switch that. All right. Actually, I'm going to write number 8 first before we talk about 7. Okay, Jesse, what should we do first on 7?
You're gonna add 7 to 12 and subtract x from 4x.
Yeah, I would do the x's first just to make sure you're getting everything away from the x's. So if you got x's on both sides, you want to get rid of them. Since x is added, to get rid of an added x value, you would subtract x.
And you're gonna add 7 to both sides. And then you're gonna divide it 3, but it doesn't
to get a fraction. 19 divided by 3 is just 19/3. Does not reduce. Alright, Brianna, you got the big one. What do you think we should do first? What do we do when there's a number next to parentheses right there? Yeah, multiply both of those by 3. 3 times x, and 3 times minus 2, -6. Okay, you know what we can do on the right side? Over here? We can add our like terms, so 6 plus 4 is 10, and the minus 2x is still there. Do you know what Brianna, do you know what we can do on the left here? Yes, x plus 3x is 4x. And what do we do if we have x's on both sides? We need to get rid of them on one side, so how would we get rid of a, let's say a minus 2x, how would I get rid of that? Plus 2x, the opposite. Those cancel out, but if you do it to one side, you have to do it to the other. Alright, that's a lot of work. Okay, actually, right, number 10. Oh, and you didn't know that telling Wyatt to go first is gonna come back to bite you. He got the easy one, you're gonna get the harder one. Whoops. what should we do on 9?
First we subtract 7.
Subtract 7.
On the other thing, you multiply by 6.
Okay, times 6. The divide 6 cancels out. Okay, this was on the graph is where I advised you to make floating lines first. So actually on the test, they already made the line for you. If the numbers that you get are not on the number line that they made, you know you did something wrong. Okay, anyways, so for the floating line, what's x is greater than or equal to 3 look like? Closed circle, Moses going which way?
Oh, closer towards the right.
What's x is less than or equal to 12 look like?
Closer towards the left.
Okay, and there was an and in the middle, so if there's an and, what are we gonna use?
We are going to use the 2 dot, or 2 close circles connected.
Right, and means both, that's what and means. Where are they both at? All in here, right? So it's between those two closed circles. Alright, I think it's all right. Yeah, do I want to write number 11 down yet?
Yes, you do. Please use
Okay. Yeah, I'll write 11 down. Alright, Miranda, what do we do on the left one over here on number 10? Then,
Divide by
what happens when you divide by a negative?
switch.
Yeah, the inequality switches. Okay, so over here, kind of the same thing, plus 12. Divide by positive 4, so the sign will not switch. Oh well. Alright, so it's got a -3 and a 2. Okay, so for the floating lines, Miranda, what's x is greater than or equal to 2 look like? Open or closed circle? Closed going to the... Yep. And what's x is less than or equal to -3 look like?
Close circle going to the left.
Yes. Alright, I wonder if the one on a test is like this actually. Didn't look close enough. So what's our final answer gonna be? If it's an or, what are we gonna use?
No solution?
No. No. We'll never understand and or, will we? Okay, if it's or, it can be either of them. So it's okay that they don't have anything overlapping. But is this stuff in the middle included? No, it can be this or this. So it's just gonna stay the same in this case. If either of them are part of the answer, then it's part of the answer. change anything on that one. Now, I'm not sure if the one on the test is like this or not. So let's say if they were going in the same direction like this. If it was an and statement, what would you use?
All numbers in between.
The all numbers in between.
There are no numbers.
Or-
Okay. They're not going in opposite directions. What they both have in common is all these numbers. So that would be an and answer. But if it's an or answer, what do we use? Okay, if it's an or, use if this is covering it or this is covering it as part of the answer. So the or would start all the way back here. Basically that one. Okay, so and's got to be both. Where are they both at? Or it can be either. So they're all the numbers here on over are covered by either this or that. Alright, anyways, moving on. So we got absolute value equals. We did this during the fall break week. Looks like there's only one of them actually. Back to red. Something else. Okay, these are all absolute value problems, kind of like 3 and 4. We're not graphing. So they're all going to set up a little bit weird. If you only solve them like they're normal, you're only going to get like half credit on these. Oops, that's not what I wanted. So, and how does absolute values equals set up?
Wouldn't it just set up regular? It would just be 3x minus 7 equals 8 and then you just solve it?
No. Okay, Avery?
Wouldn't it be like an or statement, 3x minus 7 equals 8, or 3x minus 7 equals negative 8?
Yes. Because the absolute value makes everything that was negative positive. 3x minus 7 could actually equal negative 8. So yeah, you gotta set up as two different things. Like that. And then, well, that's the hard part. After that, you just do the normal stuff. All right, number 12. Brooke, how's that one? How did the less than set up?
You would do negative 7 less than 5x is still less than 7.
Good job. Yes, you would. So it's kind of like number, was it 3 or 4? It's kind of like number 4. Absolute value less than sets up between. And then when you do tricks, to get x by itself in the middle, you have to subtract 2 on all 3 sides. It's a little bit different. Kind of ran out of room. So, Brooke, what would we do at this point?
Divide by 5.
Divide the 5 away. That'd be it. Alright, Corbin, how did absolute value greater than set up?
It would be, 4x plus 8 is, equal to or greater than 12, or, 4x plus 8 is greater than or equal to.
No, the greater than switches on the second one, so it's less than or equal to, and then they both switch. The greater than switches and then negative positive switches to negative.
So, on the first side, you would, subtract 8 to 12, which would be 4, and then divide by 4.
And same thing over here, subtract 8, divide by 4, like you said. Whoops. Alright. I don't know if I want to do the next two, it's kind of... Okay, maybe I'll skip it and come back to this. If we have time, I think we will. Alright. Well, this next part isn't really math. It's story. Well, not quite. Let me make sure I get them all. Exceeds, at least, at most, not greater than or equal to. Okay, these are very quick to do, so you could get a lot of points quickly or a lot of points wrong quickly. Not greater than or equal to. Okay, my advice is think about it in terms of like money or age or something. So if your age exceeds, like, say, whatever, 14 years old or 13 years old, what does that mean?
Greater than.
It's greater than. All right? Greater than. Kind of a hint is there will be like one of each for these four, one of each of the symbols. If your age is at least 14, what does that mean? Okay, if I said you're at least 14, you could be how old? You could be 14, right? If you're at least 14, you could be 14. But yeah, that's greater than or equal to. So if you guys are at most 16, what does that mean? Less than or equal to. You could be 16, or you could be younger than 16. if you forget which one, if you guys are still having trouble recognizing greater and less than, maybe make a little problem off to the side, like 2 what 1? 2 is what compared to 1? Greater than, so that's a greater than. Or 1 is less than 2. The mouth always eats the bigger one. So 1 is that's a less than, 1 is less than 2. So if you write that off to the side, that can help you think which. I know exceeds means more than, but which of these means is greater than. So if you make a little thing like this, maybe that can help you remember. That first one is greater than. Okay. Well, you can kind of cheat by process of elimination. So it says not greater than or equal to. This is greater than or equal to. So what's not that? What's the opposite of greater than or equal to? Less than. It's also kind of the only one we have left. And it is kind of like that on the test. I just switched the order up, basically. We're not done. We're getting close, though. Okay, let's say, I'm not going to write this all down because it's like a paragraph, so you guys will just have to listen. Let's say you guys had $400 in the savings account, in your savings account at the beginning of the summer. And, I don't know, what are you going to spend the money on? Shoes. In Miranda's case, it would be shoes. Clothes. Owen, you're a shoe guy too? Who's got more shoes between the two of you? Owen, you're a rookie. All right. Just kidding. I got like 3 pairs. Good job. Good job. Okay, we're getting off topic here. Let's say you start with, what did I say? $400 at the beginning of summer. And every time you go shopping, you buy, we can't make this too bad. Let's say it's like $80 pair of shoes. Every time you go to like the mall or something, you buy an $80 pair of shoes. How many times can you go shopping and still have like $100 left at the end of the summer? Okay, I want the inequality written and the solution. So every time you go shopping, you spend $80 on a pair of shoes. How many times could you go shopping and still have at least $100 by the end of the summer? Okay, so the question is, how do we set it up? So if we're spending,
So you do 400 minus 80x?
Yes. You're going to lose $80 times however many times you go shopping. Now are you leaving? Okay. And we want to have at least $100 at the end of the summer, so how would I write that? We need at least $100. Okay, greater than or equal to $100. Okay, that's how you'd set it up. This one's not going to come out perfectly. I wonder if the one on the test does. Didn't really look. Yeah, the one on the test will actually work perfectly. So maybe I'll change my number so it works nicely. Let's change this to well,
You wanna have at least like 120 or something?
it'd be either 80 or 160. Let's go. Let's say 160. Let's pretend that was 160. It'll work. That way we don't get a fraction. You could still answer it with a fraction, but I don't want to make it more confusing than it is. How would we solve this? I just said Kenton like 2 seconds ago. Subtract 400. Divide by negative 80. What happens when you divide by negative? thing flips. It's called inequality. So you could at most go shopping 3 times.
Oh, not my budget.
Okay, I do want to mention one. There's a couple more problems. I'll just do one of them though. I think we should be good. Just need an example. Okay, so it's just a solve problem, but it's an and in it. We're not graphing or anything. So I'm gonna do like we did on the homework. You can just solve these normally, so no tricky part. But what I wanna mention is, if you simplify completely like I did on the odds, I'll give you a bonus point. If you get that part wrong, I won't count it off. So what I mean, you guys know what I mean? So you guys did this part on the homework, right? You subtracted, divided, all that good stuff. There's 2 problems like this. Okay. Now on the homework I said you could stop right there. But remember when I did the odds I said, well, what does that simplify to? So it'd be like asking you, and you might draw, you don't have to draw a graph, but you might draw a graph to help you figure it out. What numbers are less than 3 and greater than or equal to 4? No.
Every other number?
Okay, here's the graph. What numbers are less than 3 and greater than or equal to 4?
No numbers.
Nothing. No numbers are both of those. So this would be no solution for the simplified answer. And if you try that part, I'll give you, if you get it right, I'll give you a bonus 1 point. I'm not going to give a lot on this. Okie dokie.